Alrighty, let's continue with section 4.3, which now we're gonna look at the properties of logarithms. The reason we're going to be interested in these properties is because when we go to solve log equations and exponential equations, these properties are going to be helpful in order for us to do that. So there's a couple of rules. We have a product rule, a quotient rule, and a power rule. So let's start with the product rule. So the product rule for logarithms, says that if I have log base b of a product, let's call it m times n, then that's equivalent to log base m plus log base b of n. So the logarithm of a product is the sum of the logarithms. So for example, let's look at example 1. Use the product rule to expand each logarithmic expression. So in A, I have log base 6 of 7 times 11. So I could write that as the sum of log base 6 of 7 plus log base 6 of 11. And you know what? Let me take this opportunity to show you in the calculator how to enter a log with a base other than 10, right? Because whenever we use that button on the calculator, the log button, we're assuming the base is 10. So if I want to type in log base 6 of 7, I can't just use the LOG button because the calculator is going to think that I want log base 10. So we have a function in the calculator. So let me share my calculator. If you guys go into math and arrow over to number and scroll all the way down, wait, I'm lying, I'm sorry, stay in math and scroll all the way down. So go into math, scroll all the way down to the bottom. And this is so slow, I apologize. You see how it says log base? You're going to choose log base. Now, if some of you have the older calculator and you don't have that option for math, you're going to have to change the base manually. And I'm going to show you how to do it at the end of the video. So just hang tight. So if you don't see this, I'm going to show you how to do it in a little bit. So don't worry. Those of you that have log base, let me just show you how to use it now. So we choose log base. And now your calculator is saying, okay, give me the log, which is 6 in this case, and the base is 7. I'm sorry, x is 7. So the base is 6 and x is 7. So now it's going to give us log base 6 of 7, which is about 1.086. And what I want you to see that these are in fact equal. So now let's do log base 6 of 11. So math. So log base 6 of 11 is about 1.338. So if we add those two, so if I take 1.086 plus 1.338, I get about 2.424. Now remember what we're saying this is equivalent to. We're saying that this is equivalent to log base 6 of 7 times 11, which is 77, right? So isn't this log base 6 of 77? We're saying it's equal to log base 6 of 7 plus log base 6 of 11. So let's check that they are in fact equal. Let's type in log base 6 of 77. And we get 2.424, right? They're the same, little bit of rounding error. So let's go back to the worksheet. So B says log of 100 times x. So we could rewrite that as log of 100 plus log of x. And we could actually simplify log of 100, right? Isn't log of 100 just 2? Because it's 10 to the what power gives us 100, right? It's 2. So this is equivalent to 2 plus the log of x. So that's how we use the product rule. We also have a quotient rule. So if I have log base b now of a quotient, m divided by n, we could rewrite that as the difference of the two logs, log base m minus log base b of m minus log base b of n. So the logarithm of a quotient is the difference of the logarithms. So let's practice that. So for A, I have log base 8 of 23 over x. So I'm going to write log base 8 of 23. Just write this a little bit lower. So we have log base 8 of 23 minus now log base 8 of whatever's in the denominator, which is x. So I could write it as a difference. And let's look at B. So we have the natural log, and the same holds true for natural logs, whether it's log or lm. So the natural log of e to the 5th divided by 11, so that's the log of a quotient, right? So this is going to be the natural log of e to the 5th minus the natural log of 11. I could simplify this further. The natural log of e to the 5th is 5. So this is going to be 5 minus the natural log of 11. And the reason is, look, I notice I have base e here, so I'll write this up here. Natural log of e to the 5th, but we're also in base e, right? Whenever I see ln and I don't see a base, it's e. So this is basically saying e to the what power is equal to e to the 5th. And that power would have to be 5, right? So we end up with 5 minus the natural log of 11. And we have one more rule. We have the power rule. So the power rule we're going to use a lot. So it says if I have log base b of m to some power p, I can rewrite that exponent as a factor, as part of a product. So p times log base b of m. So the logarithm of a number with an exponent is the product of the exponent and the logarithm of that number. So for example, look at example 3. So A, we have log base 6 of 3 to the 9th. 9 is the power. So I can rewrite that in front as part of the product. So 9 times log base 6 of 3. For B, we have the natural log of the third root of x. Now, whenever I see a radical and within a log statement, I try to write the radical using exponent. So the third root of x is the same thing as x to the 1/3. They're equivalent, right? We learned that in chapter P. So now I could use my power rule. So that exponent 1/3 comes to the front by multiplication, and it becomes 1/3 times the natural log of x. And then we'll do one more. So C, we have the log of x plus 4 squared. So I have an exponent. So we're going to rewrite it as part of the product. So 2 times the log of x plus 4. So that's how we use the power rule. Now let's kind of put it all together. Let's put those 3 properties together. So let's look at example 4. So it says, use logarithmic properties, whether it's the product rule, the quotient rule, or that power rule, to expand the expression as much as possible. So I'm looking at A and I see I have log base B of a product, right? X to the 4th times y to the 3rd. So I'm going to use my product rule. So I'm going to rewrite this expression as addition. So this is going to be equal to log base B of x to the 4th plus log base B of y to the 3rd. But now I could also apply my power rule, right? The powers come to the front by multiplication. So I'm going to have 4 times the log base B of x plus 3 times the log base B of y. B, we have log base 5 now of a quotient, a division, right? I have x squared divided by 25. So let's write it as subtraction. So I'm going to have log base 5 of the numerator, which is x squared, minus log base 5 of the denominator, which is 25. And I see I could use my power rule now with the first expression, right? Bring that 2 in the exponent to the front. So it's going to be 2 times the log base 5 of x minus, and I can evaluate log base 5 of 25, right? That's just 5 to the what power is going to give me 25, and it's 2. So log base 5 of 25 is 2. So I'm just going to simplify that. So we have 2 times log base 5 of x minus 2. We'll do one more. So we have log base 5 of the square root of x divided by 125 times y to the 3rd. So I actually have a couple things going on here. I have a quotient. This is a big fraction, but within the denominator, I have multiplication. I have a product. I have 125 times y to the 3rd. So I'm going to have a couple of things going on here, but let's start with the bigger picture, right? The big picture is this division. This is a big division problem, but there's multiplication within. So let's start with division. And I'm also going to rewrite, first, let's just rewrite square root of x as x to the 1/2. So this is going to be log base 5 of x to the 1/2 divided by 125 times y to the 3rd. So we're going to have log base 5 of the numerator, which is x to the 1/2, minus now log base 5 of the denominator, which is 125 times y to the 3rd. Now I could use my product rule. So I'm going to have log base 5 of x to the 1/2 minus, and now I'm going to put parentheses around this because I'm writing it as a sum now. So this is going to be log base 5 of 125 plus log base 5 of y to the 3rd. And now I could use my power rule because I have x to the 1/2, right? And y to the 3rd. So I'll continue this down here. So we're going to have 1/2 log base 5 of x And I can also distribute, because this is in parentheses, right? We're subtracting both expressions. So I could distribute the negative. So this is going to be minus log base 5 of 125. And then now distribute the negative again. So minus, and I'm also going to use my power rule. So bring the 3 down to the front. So 3 times the log base 5 of y. And I can also simplify log base 5 of 125. It's 3, right? Because 5 to the third is 125. So my final answer is going to be 1/2 log base 5 of x minus 3 minus 3 times the log base 5 of y. So you have to start looking for these things because this is going to be helpful, like I said earlier, when we go to solve equations that contain exponents, exponential equations or logarithmic equations. So these are going to come in handy. So it takes practice, but that's why I'm trying to kind of give you a combination of different problems just to kind of apply all these different properties. So now let's go the other way around. So now let's condense the logarithmic expression. So we've been taking these expressions and expanding them by using our properties. Now, what if they're already expanded and we want to write it as a single logarithm? So that's what we're going to do in example 5. So I have log base 10 of 25 plus log base 10 of 4. So remember, if we're going to add two logs that have the same base, we could rewrite it as one log and take the product. So this is going to be the log of 25 times 4, which is the log of 100. And the log of 100 is 2. So that actually simplifies to 2, log of 100. So let's look at the next one. So the next one we have log of 7x plus 6 minus the log of x. So I see we have subtraction, so I'm thinking quotient rule, right? So I'm going to rewrite this as a single log, but of a quotient. So we're going to have the log of 7x plus 6 divided by x. So that's my single logarithm. And let's do one more. So let's look at C. So we have 2 times the natural log of x plus 1/3 times the natural log of x plus 5. So I see now I have a factor in front of the log statement. So that's a result of using the product rule, right? Bringing the exponent down to the front. So why don't we do that first? So let's rewrite 2 ln of x as the natural log of x squared. And then I have 1/3 times the natural log of x plus 5, which is really the natural log of x plus 5 to the 1/3. Right? Because they were both brought down to the front by multiplication. And now I see I have a sum, so I could use my product rule. So this is going to be the natural log of x squared times x plus 5 to the 1/3. And I could write this rather than writing the fractional exponent, we could write it as a radical, right? Isn't this the same thing as the natural log of x squared times the third root of x plus 5? Right? The third root of x plus 5 is the same thing as x plus 5 to the 1/3. And now I have a single logarithm. The the last thing that I'm going to cover in this section is the change of base property. And this is what I was explaining at the beginning of the video when I showed you how to change the base on the log function by going into the math menu on the calculator, right? And you could pick log base. If you don't have that on your calculator, this is how you're going to change the base manually. And I'll show you how to enter it into the calculator. So for any logarithmic bases, a and b, and any positive number m, then log base b of m is equal to log base a of m divided by log base a of b. What does that mean? Look, we'll do an example. Whenever we have because a in this case, like for the common log, a is just 10. So log base b of m is equal to the log of m divided by the log of b. If we're talking natural logs, the log base b of m is going to be the natural log of m divided by the natural log of b. So look, let's do an example. So if I have, so here's example 6. Evaluate log base 7 of 2,506. Another way that I could evaluate this in the calculator if I don't have the change of base function in the calculator is take the log of m, which in this case is the 2506, and divide it by the log of the base, which is 7 in this case. And the common base now for log is 10. So we're going to type this into the calculator as log 2506 divided by the log of 7. And we'll do this together in the calculator. So this is another way to change the base manually. So we said, okay, we're taking the log of 2506 and we're dividing that. Make sure you put the 2506 in parentheses. We're dividing that by the log of 7. And we get about 4.02. And I want you to see you're going to get the same thing if we do the change of base in the calculator. So look, go to math, go down to log base if you have it. So this is log base 7 of 2506. And we get the same answer. You see 4.02199. Now let's evaluate log base 5 of 13 using the change of base. So this is going to be the log of m, which is 13, divided by the log of the base, which is the log of 5. So log 13 divided by log 5. So we have log 13 divided by the log of 5. We get about 1.59. We'll do one more. Log base 6 of 17. So that's going to be the log of 17 divided by the log of 6. So we have the log of 17 divided by the log of 6. And we get 1.58. And I want to show you, you could use a natural log too. If I were to take the natural log of 17 and divide it by the natural log of 6, I'm going to get the same thing because now all I did was just change the base. Instead of 10, now we're in base E. So if I take the natural log of 17 and divide that by the natural log of 6, I'm going to get the same answer. So that's how we change the base manually. And you could do it whichever way you're more comfortable with, whether you use the function in the math menu in the calculator or you change the base by hand. So we get the same answer. And that wraps up section 4.3. In the next lecture, we'll cover section 4.4.